Last time we spoke about conjugate priors, which essentially means you have a prior belief system about the distribution, okay? And then you take that and you see some data, you see some evidence, and you change your belief system. So that's the Bayesian framework. I'm Eitan Farchi from IBM Haifa Research, and I'm going to give you an example of how you do that, specifically with the beta function. So the beta function captures your belief system about potential distributions of, say, a coin toss. Okay? So it could be a fair coin, which is half-half, or it could be not fair. And then it will have some other probabilities, and the beta distribution captures all your belief system about that. Okay, so basically here you see the beta density, which essentially means that, and we'll do that in a different video, that the average of the beta variable is this, which basically means that if A and B are equals, you will get a half. So your belief system is that it's fair, otherwise you get something else. Okay? And now what I want to do is I want to show you how I update my belief system, okay, when I see some coin toss. So basically I get a coin toss. So look at this. This is the Bayes rule. Okay? And the Bayes rule tells you that given the data, this is going to be your belief system, but you update it according to this. So you update it according to your likelihood times the prior, divided by the probability of the data. But this is proportional to just this. And we'll work with only the proportion part, because all we want to do is show that at the end of the day you'll end up with the same type of a prior. So according to the data, we'll update the prior, and the prior will again be the beta distribution. That's what we want to show. Okay? So say I have a coin toss, and I get, for each toss I get, say 1 is success, and 0 is otherwise it's a failure. And we'll denote that as Zi. So overall, the number of successes will be the sum of Zi. Okay? So what we have here is the result of n tosses of the coin. Okay? And we represent the result as the sum of Zi. Now we're going to update the probability and see what we get. Okay, let's see. So we're working with this, and I'll write it again. So this is the likelihood, and time our prior. Now the likelihood is binomial, and the prior is the beta. So what we get here is basically this, because it's binomial, times some constant which I'm ignoring because I'm working with proportions. So this times this part of the beta distribution, and again, because I'm working with proportion, this is my prior, and I'm working with proportion, so I'm ignoring the constant. Now, this actually equals, okay, to basically, here we have this. Naturally, this is positive because we have n tosses, and the maximum number of successes is n, so this is positive. And so notice here we got, we call it B prime, and here we got A prime times some constants. So basically we got the beta distribution again. So we're back to the same type of belief system, essentially, but with different parameters. And that's what is called conjugate. So the beta is a conjugate of the binomial distribution. That's what I wanted to show. So we can work with it easily and we can update it based on these rules. So we can update in that way, we can easily update our belief system without having to go into complicated computation of integrals or anything. That's what you get when you have a conjugate.